Assalamualaikum. We from course CS143, class 2C will be present about application of differentiation. Now, let's meet our amazing group members. Let's start from Alia Aisha, Noor Atira, and Suhaili. So, what you waiting for? Let's begin now.
What is differentiation? Differentiation is a process of finding the derivative of a function. It can also be defined as the process of finding the rates of change of a function with respect to it. Why we use differentiation? We use differentiation to determine the maximum and minimum values of a particular function. For your information, the rate of function is defined as dy over dx, fx, and y. To solve differentiation problem, there are three basic derivative rules that we can apply, which is sum rule. If the function f plus g, then the derivative is f prime plus g prime. Second, the difference rule. If the function is f minus g, then the derivative is f prime minus g primes. And the last one is the product rule, which is the function is fg, then the derivative is become fg prime plus f prime g. Apart from these rules, there are some other basic derivative rules. First, the power rule. Second, the quotient rule. And the rest, you guys can refer to our slide. We also can apply derivative method in our real life, which is to calculate the profit and loss in business using graph. Second, we also can check the temperature variation, and last but not least is determine the speed or distance covered. There are four applications of differentiation that we had learned, which is Rolle's theorem and mean value theorem. Second, analysis of function 1 that conclude increase and decrease. Third, maximum and minimum problems. And the last one, analysis of function 2 that conclude relative extrema, first derivative test and second derivative test.
Next, we will start with our first situation. Coffee is draining from a conical filter into a cylindrical coffee pot at the rate of 10 inches per minute. A. How fast the level in the pot rising when the coffee in the cone is 5 inches deep? B. How fast the level in the cone falling then? The solution of A is they are given that dV over dt is equal to 10 inches per minute and R equal to 3. We know that V equal to pi R square H is the volume of the cylinder. dV over dt equal to pi R square dH over dt, that times dH over dt. To find dH over dt, we need to times 1 over pi R square times dV over dt, and we just insert the dV over dt and and it will be 1 over pi R square times 10, and the answer will be 0.35 inches per minute. The second solution is to find the level of the cone falling. We know that we need to find the radius of the cone. They are given that the radius of the large cone is 3 and the height of the cone is 6. And we simplify it to R equal to 1 over 2H. V equal to 1 over 3 pi R square H is the volume of the cone, and we just insert the radius that we just find it before. So it will be like 1 over 3 pi times 1 over 2 h squared times h. We simplify it to 1 over 3 times 1 over 4 pi h power of 3, and the answer will be pi over 12 h times h power of 3. Using all the answer we get, we can find dh over dt. When dv over dt is negative 10 equal to pi over 12 times 3 times 5 square times dh over dt. dh over dt equal to negative 10 times 12 over 25 times 3 pi, and the answer will be negative 0.51 inches per minute. The second situation is a coffee had been poured into the open cylindrical glass with the radius x cm and height y cm. A express y in terms of x. B prove that the volume of the cylinder is V equal to 27 pi x minus pi x power of 3. C find the value of x in meters so that the volume is maximum. Hence find the maximum volume of the glass. The solution of A is to express y in terms of x, area equal to 2 pi r square plus 2 pi r h, 54 pi equal to 2 pi x square plus 2 pi xy, y equal to 54 pi minus 2 pi x square over 2 pi x, and the answer will be y equal to 27 minus x square over x. To find B, they are given that B is to prove that volume of the cylinder is V equal to 27 pi x minus pi x power of 3, and using the volume of the cylinder, volume of the cylinder is pi r square h equal to pi x square, y equal to pi x square times 27 minus x square over x equal to 7 pi x minus pi x power of 3. And the last solution of C is to find the value of x in meter and to find the maximum volume of the glass. dv over dx equal to 27 pi minus 3 pi x square, and let dv over dx over 0 to 27 pi minus 3 pi x square equal to 0, negative 3 pi x square minus equal to minus 37 pi x square equal to 9, and the answer will be x equal to 3. Next, to find the maximum value of the glass, d square v equal over dx square equal to negative 6 pi x are smaller than 0. X equal to 3 cm is a maximum value. So v equal to 27 pi times 3 minus pi times 3 power of 3, and the answer will be 54 pi.
Conclusion. By using the differentiation to solve this issue, we can conclude that the application of differentiation can be used in almost everything and really helpful for humans to solve a problem. An example, it can be used to find a rate of change. As you can see on the previous slides, we find a solution to know the level of a coffee in the pot rising and the level of coffee falling to the cone. Next, we can use differentiation to find minimum and maximum value. Based on the cylindrical glass question, we apply differentiation to know the value of its maximum or minimum. So from the value, we can know that the volume of cylindrical glass is maximum or minimum. Besides that, differentiation can be used to solve any other kind of problem. As math students, it is used to solve problems including limits, but you also can use differentiation in history for predicting the life of a student. Furthermore, it is also can be used in many subjects like physics, chemistry, economics, and more. Lastly, differentiation can be used to prove a statement. Sometimes not all questions will ask you directly. Some question will give you a statement, then you need to show how you prove the statement given. For this part, you can refer on cylindrical glass question B that want us to prove the volume of the cylinder is V equal 27 pi x minus pi x cubed.